Let's go through some more application problems. We got a number of problems involving applications involving number problems and consecutive integers. Okay, there's our objective: use linear equations to solve number problems, and them to solve word problems and consecutive integers, and to solve applications. So let's jump at our first one. We'll just kind of keep with their examples real quick before we work some. If a number is decreased by 36 and the result is 76 less than twice the number, what is the number? Okay. Well, notice what it's doing here. Let me get a little pointer here saying a number is decreased by 36. There it is right there. A number is decreased by 36. The result is, well, that's saying an equal sign, is what? 76 less than, well, less than what? Twice the number. So they're saying this number 76 less than, okay, twice the number. Then notice once you get to this part, you actually have an equation at this point. So we can come in here and actually solve this. We actually have something we can look at and go, okay, well, I've got n minus 36 is equal to 2n minus 76. Well, let's come in here and let's start looking at how we can kind of make this look a lot nicer. Let's solve for the n first. Let's go ahead and say we're going to subtract off an n here, and I'll subtract off an n here. Remember, that's going to be a 1. Okay, when I do that, that reduces that. Well, here, that means I'm going to have to add 76 to get rid of him. Add 76 here. That reduces that out. 2 minus 1 is just going to be an n. Is going to be equal to what? Well, we got negative 36, okay, plus 76, and that's going to give us 40. Okay, now can we go back in there and check that? Sure. Okay, plug everything back into it, and you're going to have, I do it in blue over here, we have 40 minus 36 is equal to 2 times 40 minus 76. Well, 40 minus 36 is going to give me 4. And then 2 times 40 is going to give me 80. And then 80, of course, minus 76 is going to give me 4. And so I get 4 equals 4. And that's how you can check yourself, because they're going to have us solve something and it be not true. So let's continue on. Okay, we have 3 times. Okay, well, 3 times, it's multiplying something. 3 times what? Okay, the sum of a number, what number? I don't know. Well, that automatically means a variable, and 5. There it is equal to, here it is, twice the number plus 5. Twice the number plus 5. Okay, a lot of these you're just going to be able to just read just straightforward, being very careful and intentional. And so let's kind of come in here and we'll solve this guy again. Notice here we can rewrite this as, okay, we've got 3x plus 5 all equal to 2x plus 5. Well, first things first, let's go ahead and distribute this guy, and that's going to give us 3x plus 15 is all equal to 2x plus 5. I'm going to subtract 2x from both sides because that's going to keep giving me a positive variable there. That's just personal preference. You don't have to do that. Okay, that reduces out, so I'm going to have to subtract the 15 here and subtract 15 from the 5. Well, that's going to give me x is equal to, well, what was 5 minus it? That's going to give me a negative 10. And then you could go ahead and go back in there and check it out, but we'll save on the checking. So the number here is negative 10. So continuing on with some more examples here, let's look at, how about this one here. One integer is 4 more than 3 times the second integer. Their sum is 24. What are the 2 integers? Okay, well, let's kind of come in here and let's start working this out slowly but surely. Okay, what does it have here? We have example 3. Let me see here. Come to right here where I can work it out just a little bit longer here. We've got the first integer and then we've got the second integer. Okay, well, the first integer is 4 more than 3 times the second. Okay, everything has to equal 21. So let's look at it here. Okay, so the first integer, well, what's the first integer? It says it's 3 times a number plus 4. So the first integer, let's see what it says, remember it says that, is 3 times a second integer. It's 4 more than 3 times a second integer. Okay, well, let's come in here and let's write that down. What's the second integer? We don't know, but I can say this, that the first integer is n. So the first integer is going to be 3n plus 4. Okay, well, the second integer, we don't know, but we do know we're messing with all this. So our second guy, let's see, I'll put it here. Our first is that. Well, our second guy can just be the n. Okay, do you see where I'm getting that from? One integer is 4 more than 3 times the second integer. We don't know what the second integer is, but I do know that one of them is going to be this. The first one is going to be 4 plus 3 times that guy. Okay, well, then we can go ahead and start putting everything into our equation, and I've got 3n, hold on here, 3n plus 4, okay, plus n is all got to be 24. Well, notice I've got a plus here, so I'm going to just drop that and just combine everything, and that's going to give me 4n plus 4 is equal to 24. Okay, subtract off 4 off both sides. That's going to give me 4n is equal to 20 divided by 4, and then I get n is equal to 5. Okay, we still don't know what both of them are, so you got to be careful. I found n. This is this guy. That's the second integer. Okay, well, remember, you've still got this first one here. So my second integer, okay, matter of fact, I can go put the two integers, or we found one is 5. Well, what's my first one? Well, we need to plug that back in. We got 3 times 5 plus 4. Well, the first is going to be 19. So my numbers are 5 and 19. So it gives us a note here. In this discussion, we'll be dealing only with integers. Therefore, if you get a result that has a fraction or decimal number, not an integer, you will know that an error has been made and you should correct it. Okay, basically says don't end up with a fraction. If you end up with a fraction, you did something wrong. Let's look at some definitions real fast here. Okay, integers are consecutive if each is one more than the previous integer. 3 consecutive integers can be represented as n plus 1, and n plus 2, which makes sense. If n was 1, well, 1 plus 1 is 2, and then 1 plus 2 is 3, so that'd be 1, 2, and 3. Even integers are consecutive if each is 2 more than the previous integer. 3 consecutive even integers can be represented as n plus 2, n plus 4, where n is an even integer. Okay, and then we can do the same with odds. Odd integers are consecutive if each is 2 more than the previous odd integer. 3 consecutive odd integers can be represented as n plus 2, and n plus 4. Notice it makes sense on either one. If I start with 2 and I add 2 and I add 4, well, it's always going to be an even integer. But if I started with 3, I'm always going to keep same thing. Notice you have the same exact formula on either one of these. Okay, but it just depends on what are you starting with. Are you starting with an odd number, or are you starting with an even number? Okay, kind of makes it a little simpler to help whenever you're having to figure these out in the long run. Okay, let's do a couple more here. The sum of 3 consecutive odd integers is -3. What are the integers? Let n equal the first odd integer. Let n plus 2 equal the second odd integer, and n plus 4 equals the third odd integer. Well, what does this look like? This is going to look like this right here. Okay, we've got first integer, second integer, third integer. Well, we know, since we're trying to find, what they say here, an odd integer, we're going to have, well, the first integer, like it said from our formula, is going to be n. Okay, well, plus what? Well, then remember, we have n plus 2. Plus what? Then we're going to have n plus 4. And it would go on like that forever. Okay, all of that has to equal -3. Well, notice we're having pluses here, so I can go ahead and get rid of all the pluses. Okay, and get rid of all the parentheses, and just literally write this as n plus 2 plus n plus 4, all equal to -3. Well, let's combine like terms. I've got an n and n and an n. That's going to give me a 3n. I've got a 2 and a 4. That's going to give me a 6. All equal to negative 3. Well, we can solve that. Just let's subtract off 6 off both sides, and we get 3n is equal to, well, negative 3 minus 6 is going to give me a negative 9. Divide by 3, and we get n is equal to, what do we got here? Negative 3. Okay? Well, remember, the 3 consecutive odd integers are, well, now we got to go back and plug them in. Okay? So, let's plug it in. Well, my first one's obviously going to be the n. It's going to be negative 3, okay, because it's just an n. Well, then plug this negative 3 and plug it into this part of the formula here. Well, negative 3 plus 2 is going to give me a, here, my pen didn't mess up on me, is going to give me a negative 1. Well, then how about here? How about negative 3 plus 4? Well, that's going to give me a positive 1. And if you plugged all these back in, we won't do that just for the sake of time. If you plugged all of these back in, you would end up getting negative 3. And that's how you solve that type of equation. Now we'll do a couple of Hawks examples.